Welcome to The Explainer. Today we're diving into the one force that, more than anything else, shapes a modern Formula One car. It's a relentless, high-stakes fight that's completely invisible.
So, let me ask you, what do you think is the biggest thing holding an F1 car back? You might think it's aerodynamics, maybe the driver, or just raw horsepower. And yeah, those are all huge. But the real answer, the true limiting factor, is something you can't even see.
That's it. Waste heat. It's the one thing that gives engineers nightmares. We're talking about an invisible war fought on every single lap, where winning means finding that extra tenth of a second, and losing, well, losing means a catastrophic failure on global television.
And this constant battle against heat, it backs Formula One engineers into a corner. It creates this absolutely mind-bending paradox of power versus efficiency.
Think about the rules for a second. The FIA puts the teams in this incredible regulatory straitjacket. They're telling them, okay, you only get 110 kilograms of fuel for the whole race, and you can only burn it at a rate of 100 kilograms per hour. And then, in the same breath, they expect them to squeeze over 1,000 horsepower out of it. It sounds completely impossible, right?
So how do they do it? Well, the answer is to build the most thermally efficient hybrid power units on the entire planet. We're talking about engines that convert over 50% of the energy in their fuel directly into power. To put that into perspective for you, the car in your driveway, it's lucky if it even gets close to 35%.
And just to show you how absolutely revolutionary this is, listen to this. A former Ferrari engine boss said that before this hybrid era began, if you'd even suggested an engine could be this efficient, people would have just laughed in your face. It wasn't just considered difficult, it was thought to be pure science fiction.
But here's the catch, and it's a big one. This amazing efficiency is completely specialized for the racetrack. If you took an F1 car and just drove it down the highway at a steady 60 miles per hour, it would actually burn way more fuel than a regular hybrid like a Prius. It's only efficient when it's being pushed to the absolute limit. So, if they're achieving this science fiction level of efficiency, how are they doing it? Well, the secret isn't just getting rid of waste heat. Oh no, it's about actively capturing it and turning it directly into raw performance. And the magic ingredient, the key to this whole puzzle, is a little device called the MGU-H. It's bolted onto the turbocharger, and it is without a doubt the most critical and honestly the most controversial piece of tech in all of modern motorsport. This is the secret sauce.
And if you want to get a sense of just how extreme this thing is, the engineers at Honda Racing didn't even call it a car part. Their description? A rocket-powered turbine. I mean, that tells you everything you need to know about the insane forces and temperatures this thing has to survive.
So here's how this brilliant piece of engineering works. Instead of just dumping all that super hot exhaust gas out the back, they use it to spin a turbine, like a pinwheel. That turbine is connected to the MGU-H, which then acts like a tiny power station, converting all that waste heat into electricity. That electricity can either be stored in the battery for later or used right away for an instant power boost. Genius.
But you know how it is in Formula One? Every time you solve one problem, you create a brand new one somewhere else. And all this incredible power generation creates a massive new headache for the designers, the aerodynamic cooling puzzle.
See, even after the MGU-H has done its job and harvested a bunch of energy, there is still a tremendous amount of heat left over. It's pouring off the engine, the oil, the electronics, the brakes. Every part of the car is screaming hot. And if you don't get that heat out, the car will literally melt itself from the inside out.
And this right here is the fundamental trade-off that keeps engineers up at night. To cool the car, you need radiators. But radiators are big, they're heavy, and worst of all, they create aerodynamic drag that slows the car down. So the game becomes this impossible balancing act, trying to shrink-wrap the bodywork as tightly as possible for aero performance, while somehow still getting enough air inside to stop the whole thing from catching fire.
So how do they solve it? The solution is an absolute masterclass in design integration. The cooling system isn't just some part they bolt on at the end. It's woven into the very DNA of the car's aerodynamic concept.
Just get a look at this. This is packaging on another level. Instead of having separate pumps and pipes all over the place, they build them directly into the engine block itself. This saves a ton of space, but what's truly mind-blowing is that these cooling channels are actually designed to be structural. They help make the whole chassis stiffer. It's brilliant.
And this whole system is managed with incredible precision. It's not just about shoving air through a hole. We're talking about a delicate, automated ballet.
The thermostats for the oil and the water are constantly making these tiny micro-adjustments, down to fractions of a millimeter, to keep every single fluid in its perfect temperature window for maximum performance.
And this internal battle with heat is what directly shapes the outside of the car that you see on TV. It's the whole reason teams spend hundreds of millions of dollars developing those crazy side pod shapes. Whether it's Red Bull's downwash concept or Mercedes' old zero-pod idea, they are all just different, incredibly complex answers to the exact same question. How do we get cool air in and hot air out as efficiently as possible?
So the big question is, after all that complexity, all that money, does it actually work when the car hits the track? Well, this data from a race simulation at Silverstone tells the whole story.
Check this out. Look at the car's speed trace. It's jumping all over the place, right? Full throttle, hard on the brakes, corner after corner. But now, look at the lines for the water and oil temperatures. They are almost perfectly flat. That is what success looks like. It's a system that can maintain a perfect thermal balance no matter how hard the car is being pushed.
So, in the end, the conclusion is pretty clear. In modern Formula One, mastering thermodynamics is every bit as important as mastering aerodynamics. This isn't just about making sure the car doesn't blow up, it's about unlocking a whole new level of performance that would be totally impossible otherwise.
And as we look ahead to 2026, with brand new engines and fully sustainable fuels on the horizon, this invisible war on heat is only going to get more intense. The teams that can conquer thermodynamics won't just be fast, they're going to be the ones who define the entire future of this sport.